is the second class or second chapter that we will learn for this class. For the previous class, we have learned the introduction of artificial neural network. We have learned that what is neural network. So we have learned this biological neural network, and we also learned the artificial neural network. So for today's class, we will learn about activation function. So we will learn about what is an activation function. So what is activation functions? Actually, activation function will decide whether a neuron should be activated or not by calculating the sum and further adding bias with it. The purpose of this activation function is to introduce the non-linearity into the output neuron. So for activation function, we have many activation functions. And why we have many activation function? It is because activation functions helps to control the output. So control this output. So that's why we have many activation functions. So what are the examples of activation function? So the first one is step activation. In step activation function, we have binary and also bipolar. So for the step activation, the value is either 1 or 0. If the value is more than or equal to 0, then it will become 1, positive 1. And if the x value is less than 0, it will become 0. The value is 0. And then other than step activation function, we also have sign activation. The value for sign activation is either positive 1 or negative 1. The sign function, the value for sign function is in between negative 1 and 1. So the bipolar value, this bipolar value is either produce 1 or negative 1 as based on its input. So other than sign activation, we also have sigmoid or logistic activation function. For this sigmoid function, the value is between 0 and 1. So the value for sigmoid function will never reach 1 and it will never reach 0. So we will find out how perceptron works as a simple computing element. So this is we have learned that we have many types of activation function. Now we will learn on how to calculate the output, how the perceptron works. So in previous class, we have learned that the elements of perceptron or neural network, we have the neurons. This is called neuron. This is the neuron. Neurons, and it is connected with the this connection links to the output neurons. This is the input layer and this is the output layer. And this between the inputs and output, we have connection link which have weights. and these weights needs to be adjusted or need to be updates. Why we needs to update the weights is because a neural network learns through a repeated adjustment of this weight. Of this weight. Okay, so how does a perceptron produce an output? So we have several steps of calculation. First, we need to find the sum of input products time with we need to find the summation of input times with weights, and then it will be times with bias. It will add with value of bias times with threshold, and then the next calculation is what is the function of this threshold value? So this threshold, it acts like a weight and the value is constant. And then so this value will be used as a parameter. This value will be used as a parameter for this value will be used for this activation function. So for this activation function, and for this example we use step activation. So this equation is reduced into simpler equation. So why we reduce this equation is because the value for bias is either positive 1 or negative 1. So how we calculate how we update the value, how we update this weights value? First, we have several steps of the calculation, several steps for calculating the output. So the first step is initialization. So for the weights, we need to initialize the initial weights, and then we have to set the threshold value to random numbers, which is in between negative 0.5 to 0.5. Once we initialize these two values, we will set alpha value at a low value. What is alpha value? Alpha value is actually the learning rate. Alpha value is learning rate. Then usually alpha value is set at low value. And then the second step is activation. So we need to activate the perceptron by applying inputs x1, x2 and so on, and the desired output, which is y1. So this is the same calculation as this one. So we will use this calculation for the next example. I will explain in next example. So next step is weight training. This weight training also called weight adjustment or weight updates. Okay, how we find the value of weight? So how we know that we need to adjust the weights? First, we need to calculate the error. And how we calculate error is by calculating the y desired minus y actual. So what is y desired? I will explain later. And then once we have this error value, but if the error value is equal to 0, the weight equal to 0, the weight values will remains the same, and we don't have to update the weight. Okay, once we have the error value, we need to calculate the weight change. How we calculate the weight change is okay, basically the weight change is called delta weight. So we will calculate the delta weight by using the first one is we need alpha, which is the learning rate, times with input, and then times with error. And then once we have the delta weight or the weight change, we need to update the weight by adding the current weight to the calculated weight change. So this is the equation for updating the weight. So this is the newly created weight, and how we get this newly created weight is by calculating it is equivalent to current weight. This is the current weight times with delta weight, and this newly created weight for P it is actually the current weight plus 1 is the new weight. Okay, so so the next step is iteration, step 4. So repeat step 2 with newly updated weight, which is this one, newly updated weight. But if the error is 0, the weight should stay the same value. We don't have to calculate the weight change. And then the iteration is ended when the perceptron reach 0 error for all the possible input output pairs. Okay, let's look at this example. Can a perceptron learn an or an exclusive OR functions? So this one is the truth tables for the basic logical operations. Okay, if you look at this one, this is the input variable which called x1 and x2. This combination of input will help in finding the n logical operations. This value is actually the y desired. This is y desired. So how we get the y desired is for n operation, we will look at the combination of this input. So for example, the first combination is 0, 0. For n operation, it will become 0, 0 and 1 is 0. 1 and 0 is also 0. 1 and 1 is equal to 1. So it also applies to OR operation and also exclusive OR function. So this logical operation will be used in this example. Okay, let's look at this example. Okay, if you look at this column, we have inputs x1 and x2. So this is combination, and the products for this combination will be used to find the desired output. As I explained just now, this is called y desired, and how we get the desired output is by using logical operation. And for this example, we use AND operation. So by using AND operation, we will get this desired output. So this combination will also helps the products of the combination of inputs will also help in finding the actual output, which is y. So this is the initial weights, which call w1 and w2. As I explained just now, for weights, we will initialize a random value between negative 0.5 and negative 0.5 to 0.5. If you look at this side, the threshold and the weights value we randomly sets in the range between negative 0.5 to 0.5. Okay, and then this applies for both of the weights. And then how we get this actual output. So the calculation to get for this actual output, we will use this calculation. We use this calculation. So let's try to calculate. Okay, based on the calculation, we will calculate the output, which is the first output, x1 times x1, this times with w1, and then plus with x2 times with w2, which is okay, and then the summation of these two value will be minus with threshold, and the threshold value is given here, which is negative 0.2, and the learning rate alpha is 0.1. So based on the calculation, the products of this and this will be minus with threshold. So if you look at this x1, it is 0 times with weight 1, which is 0.3, plus with 0, this x2, times with negative 0.1, and then the value of this will be minus with negative will be minus with 0.2, and you will get negative 0.2. So you will get this value. negative 0.2. This value, this negative 0.2 will then be a parameter for the binary type function, which it shows that the x-axis of the binary steps will produce zero value. As I said just now, if we use the step function, the value is either 0 or 1. If you look at this graph, if the value of x is more than or equal to 0, then it will become 1, which is the value is always positive. And if the value is negative, like the one that we are doing right now, the value is negative, so automatically the actual output will become 0. That's why this is 0. And then once we get the actual output, we can find the error value. So how we calculate the error value? Error value is equal to y desired minus with y actual. If you look at the y desired is 0, and the y a or actual output is also 0, so the error becomes 0 minus 0 is 0. So from the previous slide, we learned that if the error value is equal to 0, we doesn't have to calculate or adjust the weight for the adjust the final weights, so it remains the same weight that we initialized at the first. So 0.3 also stays 0.3, and negative 0.1 is also negative 0.1. And then we will do the second combination, which is 0.1, and if you look at the error, it also 0, and the weights will remain the same. This you can calculate on your own. So next we will look at the third combination, which is 1 and 0, and this error is negative 1. So once we have an error, so we need to update the final weight. So how does we calculate the final weight? Okay, if you look at this, we have error. So for this step, to calculate the weight change, we will calculate by using this formula. Okay, we will use this formula, the weight change, which is alpha times with input and then times with error. So let's look at our example. Okay, so alpha is 0.1, and then it needs to time with the input, which is 1, so 0.1 times with input 1, so it will remain 0.1, and then it will times with error, which is negative 1. So 0.1 times with 1 times with negative 1, you will get negative 0.1. So this value negative, we will get negative 0.1. So this negative 0.1 we will be used. Okay, how to update the final weights is we are using this value. We will add with the current weights. So the current weight is 0.3. So 0.3 current weight plus with weight change. So equals to 0.3 plus negative 0.1. So the current weight is this one, 0.3. The weight change is by calculating the weight change using this formula. So we will get negative 0.1 plus negative 0.1 negative 0.3 plus with negative 0.1 you will get 0.2. So this 0.2 will become the final weights for this weight 1, and then it also applies for weight 2. But if you look at the weight 2, final weights 2, you see that the value is same as the previous one. Why? It is because the input is 0. So if we times with 0, everything will become 0, so you don't have to calculate, and it will automatically remains the same as before. Okay, so this is how we calculate and output the output for the neural network. I hope you understand what I have explained. Okay, so that's all for today's class. Okay, sorry. This iteration, the iteration will be done once, and it will stop once the error for each combination, the error for each of the input combination is 0. So it will stop. So we know that we don't have to update to do the adjustment of the weights. So this is the final iterations. So that's all for today. Thank you.